Hello, and welcome to this International Society of Automation webinar. My name is Matthew, and I'll be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenter. And just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenter. With us today is Donald G. Dunn, Professional Engineer, IEEE Fellow, ISA Fellow, and Principal Consultant with W.S. Nelson. To read more about Donald, please look at the Speaker Bio window right next to the main presentation window. And Donald, welcome to today's event. And with that, I will pass things along to you to get started. Please go ahead.
Thank you, Matt. Welcome, everyone. I'm glad y'all could join us today, and hopefully y'all will pick up some things about alarm management. What I'm going to be talking about is an overview of the alarm management standards that are out there and available to you. Specifically on the agenda, what we're going to cover today is the importance of alarm management first. We'll hit on the history of ISA 18.2 and IEC 62682, which are the principal documents from a standards perspective out there that hopefully you folks are using on your alarm management within your facilities. We'll talk about the alarm management life cycle, and that's really only briefly going to get that at a very high level. And then we'll do a quick summary and wrap up. So let's go ahead and get started. So the importance of alarm management. When you look at how alarms are used within facilities, alarms are often as an IPO or safeguard, which helps prevent incidents. And one of the things that myself and co-chair of ISA team tend to like to do is we take and read CSB reports and other incident reports, and have been doing it for a number of years, and we have found in many of those reports that alarms tend to continue to be one of the initiating factors or causal factors within a number of the incidents that you see within process industries globally. Let's move to the next slide. So the cost of poor alarm management. Why is it, how does it impact your bottom line? So it's recognized as a common problem within industry. Alarm management, the ASM consortium has done some substantial research, and they have actually estimated that the cost just to U.S. industry exceeds about $20 billion a year. As I mentioned earlier, that it's often cited as a causal factor in many of our incidents within the process industry. And then when you look at, when I started in the industry back in the early 90s, many of the control rooms were the board mount type control systems. We were just starting to adopt some of the DCS type control systems. So when you walked into a control room, you could see the status of the process plant on the wall, literally. And as we've taken those type controls and migrated them into a distributive type control system, there are more and more features, more and more alarms, and we'll hit on that in a little bit also. And then many alarm systems aren't monitored at all. It depends on the process, right? So one of the things that we have found is the cause of abnormal situations. Human error, it tends to be the largest causal factor, and then of course equipment failure and process. let's move on. So why human or other errors? Why is that the impact? It's the weak leak. We've had operator consolidations, and then there's a lot of opportunities within the distributed control systems as well. So let's continue on with the cost of poor alarm management. So we already hit on that bullet, and we've already hit on that one, but it's been cited in these specific incidents. It's one of the causal factors. Specifically, if you go look at the CSB report for BP Texas City, you'll find it as one of the causal factors that contributed to that incident. So the drivers for improving alarm management, it's recognized as a common problem, and this is, since the advent of the distributed control system. And I keep hitting on this factor that's often cited as a causal factor. But there are business drivers as well. If we look at safety and environmental performance, many organizations that do alarm management improvement projects find that they improve both safety and environmental performance, but they also improve quality, cost, and uptime. From a quality standpoint, if the operator doesn't miss alarms, it helps them ensure that the product quality stays on spec. And then, of course, the cost, when you have a catastrophic incident or even a minor incident, you can have substantial equipment damage. And then uptime, by keeping the process within the bounds of the operating conditions in lieu of outside that bounds, you tend to not have upsets, and the process unit would tend to operate much more smoothly. And then finally, linking alarm management improvements to the bottom line. So this is one of the comments I say it's sometimes difficult to quantify how you can have a reduction when you're talking to management. When you say, okay, well, we can implement alarm management and it's going to mitigate us from having catastrophic incidents. They tend to want to have a more quantifiable number. And Nick and I actually wrote a paper a little over a year ago, and we provided some quantifiable numbers on how to tie that back to doing alarm management projects. And then job retention as well. We've actually seen a process incident in the Beaumont-Port Arthur area. I haven't seen the CSB report on it yet, but it was a pretty substantial incident, and the process plant is shut down, and last I heard it was going to be down for in excess of a year, and all the employees were laid off. So that is a impact of not operating the facilities and keeping them up and running. Okay, let's continue on. Drivers for improvement. Operational excellence is certainly one of the drivers for improved alarm management. It starts with operator discipline, doing the right thing the right way every time. The alarm indicates the operator the right time for them to take an action and the right action for them to take for that specific alarm. Alarm systems are the good indicator of operational discipline if we're doing them appropriately, right? And this includes operations, maintenance, technical, and management functions as well. And then, of course, OE impacts business performance. And then the basis to expand the effort in alarm management activities helps us improve our safety and our business performance. So this is a facility I worked at in the late 90s through the early, basically 1998 to 2006. I was at this chemical plant. And this is a operator console that we did an alarm management project on. And so what you see in this 24-hour period is a total of 2,053 total events that the operator saw. 983 of them were alarms, and then 1,070 of them were actual operator actions, basically them making set point changes or acknowledging the alarm or whatever action the operator took. So as you can see, there are more alarms than the operator needs, number one, and many of the alarm management features weren't used here. And basically, when you look at that number of alarms in that period of time, if we had a critical alarm that could impact the environment or prevent damage in equipment or a catastrophic event, the likelihood of the operator being able to pick that alarm out and be able to react to it is not high. Okay, so let's look at the control panel, like I mentioned earlier, to the DCS control system. So we've migrated from, hopefully y'all can see the pointer, from this here to this here. So distributed control systems replaced the old panel mount type control systems where it was basically the wall, right? All your instruments were, or controls were mounted in the wall. And then what we've seen is the number of tags or data points has increased exponentially. In addition, the space to display this information is decreased. So you look at, we went from a wall mount to basically computer screens, and then the area of responsibility has increased. You know, we've had incidents where, at least in facilities I've been at, where we've had more than one operator condensed down to one inside operator controlling more than one unit. So increasing point count per operator, decreasing display area per operator as well. So this increasing alarm count, the panel alarms were space limited. It was expensive to add alarms, so you tended not to put in alarms unless you absolutely needed them. Within DCS realm, the viewpoints, all alarms are free, right? And so each tag can have multiple alarms. And I've seen this in areas where we went in to do an alarm management project, where you have one tag with, you know, just an inordinate amount of alarms, right? And many alarms are set because the viewpoint is that they're free. So increasing alarms per point, decreasing cost per alarm has kind of driven this issue. So when you look at our alarm system problems, DCS has been kind of the alarm problem in a nutshell. And you can see the graph here. This is shows you that from 1960 to roughly 2000, our alarms per operator position configured have increased exponentially, and the alarms per day have gone up substantially. As you look at that screen captured, those are alarms in a particular process plan as well. So 1,000 alarm events that cannot be evaluated by the operator. Which alarms are safe to be ignored by the operator? That's the question that each of you needs to ask. Which ones are safe for them to ignore? So alarm system problems summary. So past, alarms had a dedicated point, very few alarms. Each alarm had a response. Each alarm was documented. You know, basically when you look at the panel alarm, everyone knew what each of those alarms meant and what they needed to do to respond to them. Today, alarms share the same space. We have thousands of alarms. Many of them have no response. Many of them have no documentation. I've seen that many times doing alarm management projects when you'll see a good example of alarms is you've got A and a B pump. The A is running, the B is not, and the B is in alarm because it's not running. You see that in almost any facility that you go do an alarm management project. All the equipment that's not running is typically an alarm. That's a good example of alarms that should not be on the screen. So common alarm problems, alarm overload. It's a substantial problem within the process industries. So when we look at the next one, we've got alarm floods. Alarm overload, you've seen the screen of alarm overload capture of a facility. Alarm flood is when you might lose a compressor and the operator gets hit with hundreds of alarms for that piece of major equipment. Stale alarms, we talked about that. We got A and a B pump. The B pump's not running, it's an alarm for however long that it's not running. That's considered a stale alarm. Nuisance alarm, you might have an alarm that's basically vacillating around the set point, and so it's going on and off and on and off. That would be considered a nuisance alarm. Alarms without a response, you'll often see that. Alarms where the response is the operator pushing the acknowledge button. That's not an alarm, right? When we look at the definition of alarm, you'll see what I mean. Alarms with the wrong priority, we can go into that and more detail if we cover a more expansive view of this presentation, but I'm not going to get into that today. Redundant alarms, so it could be where we have a high and a high for the same tank, right? And then bypassed alarms. That's where people have alarms in bypass or jumpered out for extended periods of time. I've seen incidents in facilities where I've done alarm management project where the alarms were actually bypassed for years. I mean, we're not talking days or months, but we're talking literally years. So this is that same facility again. And on the left was prior to the alarm management project. And on the right is the alarms per day after the alarm management project. So this is before alarm management, after alarm management. So, the question is, to get a different result, we need to do something different. Bottom line. So what's a good alarm? So this is the definition of alarm management. Alarm is an audible and or visible means of indicating to the operator, okay, an alarm goes to the operator. That's fundamental. Alarm doesn't go to the engineer, alarm doesn't go to the maintenance person, alarm goes to the operator. An equipment malfunction, process deviation, or an abnormal condition requiring a timely response. That is fundamental. This is the definition on ISA 18.2 and IEC 62682, and this is fundamental to proper alarm management. So key design principles. Every alarm should have a defined response. What does the operator do when they receive the alarm? And if it is just to push the acknowledge button and be aware that something happened, that's not an alarm, and you've got to push back on the facility when they try to deem an alarm that just pushing the acknowledge button. You have to have adequate time for the operator to carry out whatever that response is. And that's critical. If what they need to do takes longer than you can, to get the process in control, then an alarm maybe isn't what you want to implement. And this sometimes you may want to look at something else, like a SIS system or some other type of means to mitigate that process hazard. Every alarm presented to the operator should be useful, relevant, and unique. That's a key factor there. Each alarm should alert and inform and guide the operator on what they need to do to respond to that alarm. And so if an operator response action cannot be defined, it's not an alarm. Fundamental, folks. So the history of ISA 18.2 and IEC 62682. So we're going to talk from a historical timeline standpoint. ISA 18.1, which is really, we'll call it the alarm, or the standard for panel alarms, was published in 1979 as a standard. That document actually goes back to a technical report many years before 1979. During that time frame there, the late 70s to the early 90s, we had a number of substantial incidents out there. And Milford Haven incident specifically caused the HSE to write a report, The Management of Alarm Systems by Bransby and Jenkinson. And that was published in 1998. Well, the ASM Consortium also conducted a lot of research during that time period. If anyone's heard of a gentleman by named Ian Nemo, Ian created ASM and conducted a lot of that research with funding from various organizations. But they also provided a lot of the research and funding to create EMUA 191. So EMUA 191's first edition was published in 1999. In basically 2003, ISA team began the effort in Houston at the ISA show. We began the effort to create the first standard on alarm management. EMUA 191, EMUA, number one, is not a standards development organization. EMUA 191 is not a standard. So that's a key delineation that folks need to understand. But in 2003, Nick Sands and I started our effort to lead the ISA team group to create the first standard on alarm management. It took us a number of years. EMUA 191 second edition was published in 2007. In 2009, we published the first standard on management alarm systems for the process industry. And this standard is pretty different from most standards that you see out there in the industry. Most standards are standards on kind of widgets, you know, equipment, stuff like that. This is a work process standard, so it's substantially different from most standards that you see within standards development organizations. So following the publication of ISA 18.2, during a number of years, we created technical reports. So one of the key things is a standard tells you what you shall or should do. The technical reports tell you how to do it. TR1 covered alarm philosophy, TR2 covered alarm identification rationalization, TR3 covered basic alarm design, TR4 covered enhanced and advanced alarm methods, TR5 covered alarm monitoring, assessment, and audit. TR5 is in the process of being, an update is being published for TR5. TR3 is in the process of working through comments for its second update. Tier 6 is covered alarm systems for batch and discrete manufacturing. Tier 7 covered alarm systems for package systems. We have a working group 8 right now that has just pulled together a draft on the management of alerts and notifications, and that's actually going to go out for comment to the ISA team working group to get feedback from them. There was a joint working group on between ISA 84 and ISA 18 working on safety alarms and a term they called SKY. That's kind of dissolved, and we're going to be covering safety alarms within an update of ISA 18 coming up later this year. APIs also created a document. I'm not a big fan of that document, but you may have interest in APIs, RP 1167. IEC created IEC 62682, and it was published in 2009. I'm the convener of IEC 62682. Nick Sands is the secretary and our technical editor of that standard. The way we manage these standards is the new work product or the new items or literature tends to come into the 18.2 document first. The IEC document, we have a lot of folks from other countries around the world, and they do a tremendous job of helping us parse the words because English does not necessarily translate to other languages. So, but when you look at the alarm management subject matter experts, the bulk of the subject matter experts in alarm management are within the ISA 18 body, not over in the IEC 62682 body. And then, of course, EMUA's third edition was published in 2013. EMUA actually has a rep that participated in IEC 62682 work during that 2009 update. We published a update 18.2 in 2015. We are not quite finished publishing the update of 62682. We finished the CDB comment stage. The document just came out of the IEC editorial process, and you know, we need to do a few things and then push it out the door to publish that new version of 62682. And then we will start later this year to update 18.2. So it gives you a history of alarm management. So let's talk about the alarm management life cycle. This is alarm management life cycle, and it's the same life cycle in 18.2 and 62682. And it includes practices that help us solve our common alarm problems. You know, it includes practices for new facilities or existing facilities. And then it is also considered RAGAGAP, recognized good and acceptable engineering practice. And it's been recognized by CSB doing incident investigations within certain facilities. So let's go through the alarm management life cycle. We'll start with the philosophy. And then we feed on into identification stage. The philosophy stage is where we write a document, a philosophy for either the company or the facility that spells out what you're going to do from an alarm management standpoint. Identifications where you go identify all the alarms. You don't rationalize them, you just identify them, throw them in the bucket, and then you move to the rationalization stage where you go through and you ask certain questions to determine, is this an alarm, right? Does it, you know, one of the key questions, is there a response, right? The next stage is detailed design. That's where we actually go in and do the detailed design of the alarms that have filtered through the rationalization stage. There are occasions where during the design, you have to step back and look at, you know, identification and rationalization. Again, might be some issues with the detailed design. And then we move to implementation. Implementations where you're implementing alarm management, you're training your operators, those type things, and then we put it into operation. Those in orange, as you can see, we've got the box on the side where we cover management of change within these areas. Once we move into operation, you can see the arrow going back and forth. There's the ability for us to take an alarm out of operation and put it in maintenance, going back and forth between operation and maintenance to ensure that your alarms are all operating appropriately. And then monitoring assessment. The only way that you can ensure that all your alarms are working appropriately is by monitoring and assessing them really on a real-time basis. And there are a number of companies and or packages that can either be stuck on an existing SCADA system or DCS system, or some of those manufacturers have actually enhanced their ability to do monitoring and assessment within modules that you can put on from those manufacturers on their control systems. And then audit. Audits, as you can see, kind of stand alone out to the side. And it's like that because the audit process is where you go in and audit whether or not you're doing what you say you're going to do within the alarm philosophy. And so the audit is sometimes you might need to tweak the alarm philosophy, or you might need to tweak through the training of the operators or others, some other parts of the process. This also builds on previous work of ASM and EMUA. So within the alarm management lifecycle, we have 3 loops. So if we look at the three loops, we've got the monitoring and maintenance loop. This is a daily or weekly process of analyzing and monitoring the data. It helps us determine a number of things. Is there something that needs to be repaired? Do we need to take and implement, advanced alarm management to mitigate some, alarm floods or things like that? The monitoring and management of change loops, less frequent, but it's a necessary process where you can roll back into that those stages of identification, rationalization, detailed design, and implementation to tweak your alarm system to eliminate different instances. It might be alarm floods, or it might be nuisance alarms where you need to go back and work on those. And then the other loop is the audit and philosophy loop, and we talked about that. That's periodic. Typically, in the facilities I've been at, we would have an operational excellence audit, and part of the OE audit was auditing our work processes like our alarm management philosophy and whether or not our facilities were adhering to the alarm management philosophy. So a summary of kind of what we've been talking about. The alarm management lifecycle, it provides a framework of activities that helps you manage an alarm from cradle to grave. The lifecycle makes it easy to connect the activities with other frameworks within the facility, whether it's capital projects, process safety, quality management, or your SIS systems. And then alarm management systems is a key indicator of OE operational excellence. It will help you, if you implement alarm management within your facilities, help you improve safety, reliability, and efficiency within your process plants. Don't wait for incidents. Design for performance of your alarm system. Use our alarm management lifecycle within 18.2, ISA 18.2, and IEC 62682 to manage your alarms. Thank you. Matt?
Thanks so much, Donald. Yep, I'm here. That was great. Thank you for that great presentation. So to the audience, we are now going to move into the Q&A session. Donald's going to stick around and answer as many questions as we can before the close of the session. And if you haven't submitted your question yet, you can still do so now by entering it in the Q&A box and clicking submit. And like I said, we'll try to answer as many as we can. If we don't have an answer for you during the live session today, we will have an answer for you following the webinar. So please send us your questions. Okay, now for our first question from the audience. What activities have the biggest impact for the operator? Donald?
So one of the key activities for an operator is, number one, making sure that you adhere to the definition of alarm, right? That the operator has a specific response to the alarm, not just hit the acknowledge button. You'd be surprised how many alarms you can call out of a system or a plant when you do an alarm management project, when you adhere to the definition of alarm management. That's number one. Number two is if you do good alarm management basis of design, right? If you go get the technical report where you look at detailed design and you adhere to some of those fundamental tenets, so good alarm design, not having highs for the same thing. When we talk about unique alarms, so if you've got a tank level, you don't have multiple alarms for that tank. If you've got an A and a B pump, if the A is running and the B's off, the B's not an alarm. You have to do a little bit more advanced alarming logic where you're only interested in an alarm if the A drops out. So those are some things that if you implement those type things, that's a real help to the operator.
Excellent. Thank you for that. And to the audience, we are in the Q&A session. You can still send us your questions by entering them in the Q&A box and clicking submit. Okay, now for our next question from the audience. Let's see. Oh, great, here's a good one. Okay, here it is. Is there any substantial advantage to using IEC 62682 over ISA 18.2 if doing alarm management in the United States and speak English?
No. They are basically what I would call mirror images of each other. And to give you a little background on how IEC 62682 came to be, when 18.2 was published in 2009, there were a couple of national committees. The Canadian National Committee, I think it was the German National Committee, and there was one of the other European national committees submitted the document, ISA 18.2 document to IEC, and said, we need to convert this into an IEC standard. I got literally an email from the technical committee chair and asked me to fill out some paperwork. I filled out the paperwork. Next thing I know, I was named the convener of the body, WG15, and that's the working group within TC65 that was tasked with developing 62682. And we literally started with the 18.2 text. And then, the individuals from around the world helped us parse wording. So the documents have a little bit of different wording, but overall, the crux of what's in them is identical. So, I would lean towards picking your choice. Now, in IEC, we do not have the TRs. The TRs only exist over in ISA. So if you want documents on how to do what the standard says you shall and should do, then go get the technical reports within ISA, and it gives you a lot of examples and underlying text on how to implement alarm management. Hopefully that answers your question.
Oh, it was great. Thank you. And thank you to the audience member that sent that question, and that was a very good one. Thank you. So we have a lot of great questions coming in, and we just need a moment here to manage them. And while we're doing that, I'd just like to, first of all, thank you for the folks that sent in praise. We have a bunch of questions in here just saying thank you for the presentation. So, you're very welcome. Thank you. All praise due to Donald, of course. And also, I just want to remind you all that the live presentation today, including this Q&A session, will be available as a replay on the Global Spec site for the next 90 days. And that will be available about an hour after today's session ends. So you can always come back and watch this again. Okay, back to the questions. Okay, here's our next question from the audience. What is the standard rule for acceptable alarm per operator per day and hour?
So that's a good question. And if you read the standard, we have a whole lot of, we call them weasel words, right? There's because it's different per industry, right? When we look at, if we go to, let me go here. If we go to this slide, I can tell you that this exceeds what's acceptable for an operator on a given day, right? And then I can say this on the left exceeds what is acceptable. This on the right may or may not be, typically in most instances we say it should be acceptable, but the numbers we have within the standard is 10 or less within a defined period. But if you go to the technical report, let me push this out. It's TR5. If you go to TR5, And we're updating TR5 right now, but TR5 gets into a lot more information than what's in the standard on what's acceptable and what you should do. And we talk a little bit in there, or not a little bit, we talk a lot in there about different industries. What's acceptable for one industry may not be acceptable for another industry. So you know, it's a difficult answer to or a question to answer. There are groups out there. There's a consortium that is in the process of trying to quantify a little bit more of what's acceptable versus what's not. They've done some simulator studies working with one of the universities where they had the individuals running kind of a standardized type script and within you know, some control systems to try to determine a response rate. And then they've also took those same control systems and had skilled operators and looked at the difference between students and skilled operators. So there's some work that is trying to quantify that more, but I mean, what's in the standard is our best guidance right now, and it comes from U and ASM and those type numbers. So I hate to be wishy-washy on that, but it depends on your industry, and it depends on a lot of other factors as well.
Excellent. Thank you for that. And thank you to the audience member for sending that one in. That was a good one. Okay, we are still in the Q&A session. We have a lot of great questions in here, so we're going to try to get through as many as we can. But if you haven't submitted your question yet or a comment, we'd love to hear from you. You could still do so by entering that in the Q&A box and clicking submit. Okay, back to the questions. All right, another great one. Do you have any advice or guidelines on setting alarms by priority?
That's actually a good question too. Well, one bit of advice is, you know, don't have just one priority. I've seen instances where everything was in one bucket. You know, typically good practice is to have it divided into typically three buckets, and you want to have your higher critical type alarms to be a smaller segment of the other categories or of alarms. So you want to follow those good practices that we have within our TR. So if you get the TR on basic alarm design, that actually goes into a lot of good information on how to delineate the your alarms in appropriate you know, buckets, you know, priorities, and how to do your different classifications of alarms as well. And then that we do TR5 also provides some guidance as well.
Excellent, thank you for that. And let's see what we have next here. Okay, another great one. Okay, here's our next question from the audience. What alarm management audit software would you recommend?
So audit, if we're talking about the audit stage of the life cycle, let me go here, push this out. So if we're talking about the audit stage, there's really not a set bit of software out there, or at least in the companies I've been at, when we've been doing audits, it was something that was managed by our HSE department to manage the audit process when we were doing our OE audits within the facility. Now, if you're talking about the monitoring and assessment stage, there are 3 vendors out there specifically that I've worked with in my career that provide software, but then there are packages that most DCS or control system manufacturers make that are basically plugged in to the control system as well. So it really depends on your preference, right? Different companies I've worked at during my career have had different control systems and different agreements with different companies to provide those type functionality. So if you're wondering specific companies, shoot me an email. You can find me out on LinkedIn. I try not to be commercial driven within presentations like this, but I can certainly respond offline to your question and give you at least the manufacturers that I've worked with in my career, but that is not a holistic list either.
Excellent. Thank you for that. And of course, thank you for the offer, for the follow-up there. That's great. So, okay, let's see. All right, we have some more time here. We have some great questions in the queue, so we're going to get back to that in a moment. But if you do have any last remaining questions, please send them in. You can enter them in the Q&A box and click Submit. Okay, now for our next question from the audience. Okay, is alarm management more successful in the more highly hazardous industries?
I might answer one just offline. Someone asked, what is HSE department? It's Health, Safety, and Environmental Department. And then I'll go into the one, Matt, that you asked. I would say the companies that have taken a cognizant approach to managing their alarms from a top-down standpoint and have worked to implement that, I would say yes, right? I mean, there is a certain company, we'll leave it nameless, but that I'm aware of that had catastrophic incidents, that had a loss of life. Alarms were cited as the principal factor that caused the individuals to die at the facilities, basically. And the CSB and OSHA came in and cited that operating facility, and that company implemented an alarm management project that was implemented globally for that company, and it was driven top down, and they have done a very good job of managing their alarms since that point in time. But when you can look at CSB reports within the last couple of years of facilities that may or may not be implementing what's in IEC 62682 or 18.2, and have had continued to have incidents, right? So, I would say the process industries as a whole, not just the hazardous industries, have been starting to implement this over, the last 10 or so years, but it's kind of hit or miss. Some companies do a really good job, and other companies not so much, and it tends to be, at least what I've seen, the companies that do a much better job have had, pretty significant incidents which have drove them to implement the best practices which you see in 18.2 and 62682.
Excellent. Thank you for that. Really important stuff we're talking about today, that's for sure. Okay, we have just about 10 minutes left in our session today. We are going to try to answer some more questions. I think we have time for 2 or 3 more. But like I mentioned, if we don't answer your question during the session, we will have an answer for you following the webinar. So if you do have any remaining thoughts or questions or comments, please send them in now. And like I said, we're going to try to answer a few more. I think we could squeeze 2 or 3 more in before the close of the session. Okay, here's our next question from the audience. What is your advice how to start reducing alarms in chemical manufacturing?
Okay, so my advice, and there's a paper, if you go to my LinkedIn page, there's a paper Nick Sands and I co-wrote that we literally talk about, this, what you need to do to implement alarm management. But, one of the key things that, if I'm at a company that has not embraced alarm management, right? One of the things you can do is start look at your standing alarms, right? Look at your chattering alarms. Look at what I call your bad actor list, and start working. Use the technical reports and the either ISA 18.2 or IEC 682 standards to start mitigating the bad actor and show your management how you're eliminating some of the bad actors, and use that as the justification, the impetus to start doing a wholesale alarm management project. And if you go to the paper that we wrote, you'll see a link in there. If you can't find it, shoot me an email on LinkedIn or to my email, and I'll send you the link to it. But it's actually a really good paper that tells you how to get started and what you should do, right?
Excellent. Thank you for that. And on to our next question. Where can we find the alarm quantifying document that Donald wrote?
If you're talking about the paper I just mentioned, there's links to it, a couple links on my LinkedIn page. If you're talking about something else, I mean, I've published a lot of stuff over the years on alarm management with Nick Sands and others. I'm not sure specifically what you're talking about, but if it's not that document that's on LinkedIn, shoot me an email of what you're asking about. I've also got a list of literally references. It's what I've kind of accumulated over the years of papers written by, Donald Campbell Brown, Ian Nemo, others, the kind of the godfathers, so to speak, of alarm management that have helped me in my career. And if y'all are interested in that, I'll be happy to share that with y'all as well.
That's great. Thank you. Okay, looks like we have time for one or two more, but let's see how many we can squeeze in here. Okay, here's our next question from the audience. How different are these standards on alarm management compared to regular operational SOPs?
Oh, that's actually a good question. At least in the facilities I've been in, our operating procedures really didn't get into how to manage and mitigate the number of alarms that the operator was having to respond to, right? Until we implemented an alarm philosophy and alarm management. And then those best practices within the standards replicated over into our operational standard operating procedures. So, I'm not sure what you have within your SOPs, but at least in the facilities I've been in, until we started embracing alarm management and the tenets within the alarm management standards, our operational SOPs really didn't address good practices within alarm management. In other words, number one, that all alarms have a unique and defined response, right? That was a number one item that was not within our operational SOPs.
Great, thank you for that. And let's see, okay, here we are. Next question from the audience. This may be the last, but like I mentioned, if we don't get to your question during the session, we will have an answer for you following the webinar. Okay, here's our question. Should manufacturers of utility skid systems, or AKA small equipment systems, should they go through the process of implementing alarm management, or is this only for plants and facilities?
So that's actually a really good question. I see Mr. Souza is the one that asked that question. And if you go back to this slide, TR7 basically gives you how to implement alarm management on package systems. And so we at least the ISA 18 committee thought it was important enough to address as a standalone TR. So a lot of times what you'll find on a package system is they don't address it at all, right? They put the package system in and then you tie it into your control system, and then you have to deal with the mess that was created in the package system. So I would say yes, it's a good idea to implement alarm management on the package system, and then of course implement it a little further as you integrate it back into your control system.
Nice, thank you.
So hopefully that answers your question, Charlie.
Oh. Very good one at that. Thanks, Donald. And we are getting to the end here, so I think we're going to move to wrap this up. Like I mentioned, if we didn't get to your questions, and we do still have a lot of great ones in there, we will reach out after the webinar. I'd like to thank Donald, of course, for that great presentation. And of course, thank you for sticking around and taking time to answer some questions from our audience. We'd like, of course, to thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version. So as I mentioned, you can come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey, which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we'll talk with you soon.